Hello, we're just giving it a few more minutes and then we'll get started. So thank you for waiting. Okay, don't want to lose any time, so we'll get started and then we'll see if more people join us in the webinar. But either way, just want to say thank you so much for joining us today. We're really excited to talk to you about transforming the daily life of drilling engineers. So just quickly, I want to introduce myself. My name is Caroline Wolf-Vaness. I'm the CEO of Pions, and I also have G with me as a speaker today, who is our CTO, and he'll be doing most of the talking. Just a few housekeeping items. So we will answer all your questions at the end. So please feel free to submit your questions either through the Q&A function or in the chat, and we'll go through them at the end. And also the webinar recording will be distributed within 24 hours, as well as any accompanying slides. Um, so we really want to focus today on this problem. So when we were going out to develop our AI-powered engineers, we were talking to a lot of customers, and we found that there's a lot of time within drilling engineering that's spent on non-engineering parts of the job. And actually, one of our customers had done some internal analysis to say that 40 to 70% of the drilling engineer's time is spent on data stuff. And when we say data stuff, we mean finding the right data, finding the right files, putting the data into the right configuration, putting that into different softwares to run simulations, rerun simulations, do calculations, and then having to copy paste results between them. And really, it all just feels really fragmented and time consuming and comes at a huge opportunity cost. So what if we could free up all of this time? And that's really what we're on a mission to do as part of building our AI powered engineer, along with a whole bunch of other capabilities. But we are building autonomous problem solvers for the industry. So AI powered engineers that can optimize, automate, and orchestrate complex industry systems and processes, and collaborate with humans and other AI agents to really fulfill the needs of engineers, and also as a bonus to that, take part of all of the non-engineering parts of the job, and allow engineers to enjoy engineering again. So when we say this, we really want this to be, this is our vision. We want a life before and after AI powered engineers. So having both in a co-pilot mode an assistant that can help you orchestrate all of these tasks, but also in autopilot mode executing on more complex processes in order to make drilling engineering much simpler. But the more exciting bit is to actually see this done live. So I'm going to hand the word over to G, who will take you through a live demo of what our AI-powered engineer, Ida, is capable of doing.
Thank you for the introduction, Caroline. So good afternoon or good morning. My name is G. Today I'm so glad to demo Ida with you. Starting with Ida, I would say Ida is our AI-powered digital engineer built on the state-of-the-art LLM and a multi-agent architecture tailored for drilling. The domain layer and the orchestration layer, as Caroline mentioned, under the multi-agent architecture handles document parsing, data management, analysis, and drilling semantics. It lets it reason across unstructured data, something generic chatbots struggle with at scale, so that engineers can get consistent, explainable answers from IDA. In this demo, I assume the role of drilling engineer, following up on a few active wells working with IDA. So before this demo, I have pre-uploaded 25 daily journey reports. This mimics the real deployment that either connects to a company database or a secure project folder, ingests some DDRs automatically, and then keeps a structured knowledge base up to date. So I begin with a big picture question, like to summarize. Let's see, what is the main information about this well? Uh, for example, when I first start working uh, with this well, I would like to know more details. So here it asked me to specify the question because the main information are too many. So I just say uh, uh, basic well details, so that to help me get started to know more about this well, since I'm just taking over from other colleagues. Of course, you can ask basic information and others, but let's start with basic information, which has like the well name, well bore name, well code, and also locations, spare time, current status, and also some attributes like listed here. This used to be the very basic information. But as engineer, I'm more want to know the operations. Like I go with Ida, can you summarize the operation section by section? Because as I can see here, the well has been drilled, and I want to know how's the operation look like for each section, or at least I haven't know how many sections there are. So those information would be very valuable for me to understand the operation during this well. So I go with this question, and Ida will use all the tools, all the sub-agents to help analyze those, summarize these, and present the final answer to me. May take some time, especially when it's a lot of files that it has to go through. Like at least I don't need to paging through all the DDRs for this well. So let's go back to the beginning of the answer. Of course, Ida did find all the informations, like summarize the section. First one is the conductor section, and gives me all the key operations, starting from jack up to drill the in and pull out of the hole from seabed, all the tripping process related with this section. Of course, casing and cementing is followed if there is any, and then she jumps to the next section, 16-inch section. Uh, that would be the surface hole and build and kickoff. Then the 12 and a quarter inch intermediate section, again with very detailed operations listed here, so that I want to know the all the information. For example, this section it also mentioned the marred weight, which is one of the key interesting point I would want to know, and also the casing cementing is followed. So all four sections are described, and at the end it was summarized in a comparison table to show the more information about each section compared with others. Worth mentioning is that the cementing steps and also the notes of events has been listed as some extras besides the main thing, like the main BHA. Since it says some key components of BHA, but I would like to know more about the details of the BHA components used in each section. So I'll just ask Ida, can you list detailed BHA components that has been used for every section we drilled in this well? uh, I was expecting to see a very detailed component list and the parameters of each component, so that I understand different BHA used for different sections. This is one of the engineering job we analyze every day for the well. So this would be well summarized by Ida, like starting with the 20-inch surface section with the main beach components listed here, like the dimension, the name, and also the amount of this pipe. So everything is listed here and summarized in a very uh, easily visible table. and we can go on and also note that the last special features and tools, this has been worth the engineer's attention that some special tools has been used for each of the section in both drilling and casing runs. So this is very detailed description for what I would ask. So these questions are mainly extract information from the DDRs without myself being needed to paging through everything and find and make all those tables with, for example, Excel. So everything is summarized by Ida, who has the domain knowledge and who has the capability to do this. So next, I would like to drill down into the daily activities. So I ask Ida, what was the daily activities during drilling this well? I would expect to see how the drilling process day by day. So Ida again helped to summarize the daily activities and put in a very organized way. For example, the pre-spart and spart operations, that was 2 or 3 days, and then goes to the surface equipment wellhead operation, another 2 or 3 days, and then uh, goes on and on. And you can see here that it does summarize very well the daily activity and put them in a small group with the same purposes like drilling manhole and BOP and wellhead installation. So I can easily see that which activity has been done in how many days and what's the details. Like if you are drilling the further intervals, how that goes with the specific depth and specific section. So this is very detailed information. If I want to learn more, I can go on to find all the details. But of course, at the end, again, it try to summarize the main activities with very dense information that to help me know the big picture and all the important informations. So these are the drilling activities. And next, I would want to think about the KPIs while drilling the well. So I go with how's the RP look like during drilling this well, the rate of penetration, of course. And then Ida comes back to summarize, since I always ask to summarize section by section, she learns how to present this by with different sections. Like here for the conductor section, the observed ROP is around 7 to 8 meters per hour, and the average value is also estimated. This is based on the different section drilling period and the fundamental calculations based on that. Of course, you could have analyzing the factors affecting ROP. For example, here, why we have higher ROP in some certain section and why the ROP was reduced. What's the reason due to there? For example, here is primarily due to the severe MARD loss, need for loss circulation. So that's what delayed the ROP during this section. So it's not only presenting the data, it's also reasoning with the domain knowledge to help you better understand it and help to make sense of this together with you. So this is the RP. Of course, RP has been very related to the MARD we used and to the whole cleaning stuff. So I next would like to know what were the MARD systems has been used for each section, because I would every section we would change the training MARD if needed. So I ask the MARD system used in each section, try to figure out more details of the training MARS so that I can make sense of the training performance and also the well conditions. So Ida again would use all the tools and agents she has to analyze this specific task and present the final answers to me, which is a very detailed analysis and summarize of what I have been asking. So let's see how Ida would go with the MARD systems. It might be a bit more data to extract, so it took a bit longer. The summary is also very clean and easy to follow. Like for each section, what is the depth interval and the size of this section, and the MARD types used, like the PET MARD, freshwater, emulsions oil-based MARD with very specific type and labels. And the MARD weight, of course, is another important thing if you're going to evaluate those. The notes are given to explain what is used and why this is used. Descriptions, more detailed descriptions are followed, and also in the summary, it would help you to make sense of why this kind of GeoMart system has been chosen for a specific purpose. Uh, so MART systems are different, and I also want to know the cost, especially the cost for each section, and maybe also compared with the planet or the budget of the cost. So that's more like the cost analysis for the MART system. So to do that, to do this specific task, I again just ask Ida do the cost analysis for the Mars in each section. I would be expecting the cost for each section along you drill deeper, which is exactly what summarized in this table. So for each section with the depth interval, for the size of the well and which MARD system has been using, and the cost section specific MARD cost is giving, and not only the cost for this section, but also the cost accumulated till this section. So this is very helpful information to help the like the performance engineer to analyze whether we are within the budget or we are out of the budget. So a very good and detailed summary is given at the end for each section, the cumulative MARD cost, the number just be accurately presenting the number for you. Next, I would really want to know the MPT analysis as one of the routine tasks for training engineers. So I asked, can you do the MPT analysis? Of course, she knows what MPT is and what should be included in the analysis. So like here, it shows with a few process like extracting data and use agents to analyze and summarize everything with this very clearly presented results, like the non-productive time analysis. So she identifies the MPT events by listing every events detected, giving the informations like start and end time, duration, activity, and descriptions of what really happened during this MPT. Of course, MPT lost money or lost hours are also very important. So she tried to summarize that uh, as well. And to help better visualize this, it presented two pie chart. Like one is the how much the MPT time compared to the total training time or productive time. So this is well described, and I would say almost only 4% of the MPT time over the total time, which is a really good job. And she also divide the MPT activities by each type, like the maintenance and repair, the various operations in the well or operations at the surface. So the maintenance and repair covers for 77.8% of the total MPT, which should be noted by the engineers. Of course, the recommendations is given based on the analysis of these data and also the domain knowledge experience learned from previous review or report. So I would say the drilling seems went on very well. So I want to have another general review of the progress, how it goes. So I tried to ask, can you check the drilling progress and compared to the planet, which I do want to see the time versus depth, for example, compared with how we planned it for this well. This is also a typical task for drilling engineers. But here it only presents one of the data, which is the actual drilling progress, depth versus time. This is down to the very details, like in few hours, as the data shows from the report. And some highlight of the progress has been given, like the benchmarks of how much depth that we drilled till which section or till what time. But if it's worth noting that in the recommendation, she does recommend that if you want a comparison with the plan, please upload and provide the planned time depth data, because we all know that in the DDR we don't have the planned data, so it doesn't hallucinate or try to make up something to compare, but she specifically asked for this data to achieve the goal I have been asking. And I don't have it here, but that's fine because I just want to see whether Ida is honest with the data she has, which is very important for to build trust and to let me uh, to let me feel comfortable to work with Ida. Of course, I'm showing this kind of step by step to show how it reasons and handle those tasks. But if you have a specified workflow, or when you have been working with Ida for some time, she knows your workflow, she knows your concern. For example, here I can just ask everything I would need and generate as a report. I'm asking, can you generate a report to include one summary of the well and summary of the operation section by section, and everything I would want to see in the report. Of course, Ida took a few seconds to generate this report and covered. Let's see whether it covers the information I need. Like this is the final report. This is very generic reporting format. Of course, it can be customized to different companies' format, but this is what I would say like the draft or the capability of Ida to see what she finds. Key findings, analysis, those are the things I mentioned or I cared most. Of course, all the information has been handled in like the well summary, the operations summary by each section, the data and realization part, and also the conclusions in the and the insights. So recommendations is also giving. This is again very generic report. This can be fully customized to a specific company's format. So that's pretty much the demo. And in this demo, you have seen how it raise structures and reasons over the data, basically 25 DDRs to produce basic informations, to produce insights, and to produce the analysis results, and also a ready to edit report. Now Ida is under internship period, which means that she learns from different company and to learn the formats, the need, and also the workflow, so that she can orchestrate and automate these workflows to work with engineers. More importantly, obviously, Ida doesn't replace engineers' judgment; it amplifies it. By doing the heavy reading and first pass analysis, so that engineers can focus on more on the strategic decisions. Once your routine is defined, it can execute this kind of tedious workflow end to end, hands free, and present to you while you just be away or grab a coffee. So hope this gave you an idea how it looks like working with Ida, and explains a bit why ambitious teams are excited to have her within the team. That's all from me. Caroline, I would like if there is any questions, I'd be happy to discuss.
Yeah, great. So well, obviously this is an example of how she can analyze DDRs, but really what we're trying to simulate here by uploading that is her having access to a range of different files and being able to take out the context from the file and provide some meaningful insights. Can you expand a little bit more on that?
Uh, yeah, of course. This is very this is the analysis based on the DDR. Of course, it's actually can be analyze any kind of structured and unstructured data, and also, for example, in the MPT analysis, different company would have different code, and IDA has in the internship period learns all the code from different companies and all the practices and roles from different company because they are usually different across companies. And by learning by the internship period, it knows how to be a specific engineer working in a specific company and how your workflow looks like and how to orchestrate and automate this workflow.
Great. Thank you. And then I think you mentioned about the final report, that we've just set up a really simple example here, but a little bit also expanding on what you've already talked about it being fine-tuned towards a company. Um, how customizable is the final report, and how does it fit to, for example, an end of well report template that a company might use?
Yeah, that's a good point. That's also one of the main tasks many engineers would be working on. So now what you have seen is a very generic report by default. So that was EDA generated so far. It is fully customizable to your company's report format. Like EDA can help add headers, edit tables, and organize the layouts so that the draft aligns with your reports. For example, as Caroline mentioned, the end of well report, we can have predefined all those contents and provide format to EDA, so EDA knows what exactly need to be outputted. And using all the information retrieved and analysis she did and the summaries she has to generate this table, to generate this report. So that'll be saving engineers tens of hours at least for manual structure and editing.
And obviously, again, here we've only been analyzing one well, but say that you wanted to do a comparison between offset wells, is that something ELA could also help with?
Yeah, good point. I think we can, let me share another window to show the capability EDA has. So again, here I try to pre-upload two DDRs. These are 101 or 102 two wells. Maybe let's just look at the drilling progress of these two wells. So I can ask EDA to analyze kind of a comparative analysis. Uh, if you can see that so in general, this is agentic AI, this is not software, so the features uh, is actually from the capability. EDA can analyze one well, then she pretty much has the capability to do multiple well analysis based on tools and the sub agents she has. So now EDA is using all the tools like extracting data and analyze the data and use subject matter expertise to help analyze those. So the drilling progress compared with the well we have seen before and another new well, she summarizes the drilling progress like with the first zero, clearly zero figure to see like one well is drilled 2023, and this is the progress. It took around 25 days, and the other one is a bit shorter, but it was drilled in 2024. And these key insights are compared in a very structured way, and analysis is followed. Of course, there are some recommendations based on the drilling domain knowledge and data from both wells. So these are presented. Of course, you can keep working with EDA to ask more, to explore more, to get more you need from your work.
Great, thank you so much. I see that our time is up and there's still some questions coming in. So if you please post your questions. If we didn't answer them live now, we will make sure that we get answered when we send out the follow-up to the webinar. So if there is anything that I haven't answered, please send it in the chat. Like I said, we will share the video and the content. And this is just one of many capabilities that EDA has. We just want to demonstrate today about doing some of the heavy lifting on the data stuff, but EDA can do a lot more both in the planning phase and in the execution phase of drilling. We also have some previous webinars that are available on our LinkedIn, so please feel free to check those out. And if you have any questions or want to learn more about EDA's other capabilities, then please reach out and get in touch with us. Other than that, I'll just say thank you for joining us today and hope that you have a nice day.
Yeah. Thank you for now.